I am Serban Teodorescu, working as the PDRE. It was almost 9 years now. Well, initially as an SRE and with working with Cassandra for about 7 years, but definitely not only Cassandra. Nowadays, part of a team that's also maintaining some Mongo clusters and MySQL. I'm based in Romania, Bucharest, so if I do any mistakes, I would blame the jet lag. For me, it's already Monday now. So, what's the scope of this presentation? We already had very good presentations about Cassandra Analytics and the Sidecar, so it is not about that. It's about using those in production for exporting data. I have a recorded demo. I was thinking of doing a live demo, but it's much better. So a lot of things might be, I might go faster over it and discuss them with the demo. How it started was a request to export actually more than 50% of the data out of several Cassandra clusters in production. And just as in the previous discussions today, the reason was to run sort of analytics tasks over those and aggregate them together with data from other systems. So not quite a data lake, but close. And the request was to do it at least once with a big asterisk that might be done again. And actually, that happened. It's a recent development. I got an ask to export them again. And then since I will have this tool, another ask to export a similar subset for a completely different reason. So once the tool is there, it becomes very useful. The clusters involve several clusters in production, single data centers with Cassandra 4 in AWS with I4I instances. What is relevant here is that on average we had about 1 terabyte data per node, about 60 or 70% of the disk space used. And also very relevant here, quite a low read-write request count. I guess most of it was about 400 per node. So, and that also means very low CPU usage. And we were using Medusa backup, and that's also relevant. So, I got this request almost in December last year, and I had to discuss the options with the extended team. Everyone knows DSBulk, the safe option. Definitely, it would have been the fastest. Easy, but with a lot of toil, and it would have required a very, very large yes to export all of that data and then push it to S3 with all the potential problems there. The other option, the old Cassandra Spark connector, yeah, everyone knows about it. The problem here was that it's also not very fast. It requires, it will either impact the current cluster or require a second data center, and that is on one hand for a one-time job that's too much. For something that might be repeated in a month or two, it does make sense to keep a secondary data center a month for a month, and with the corresponding increase in costs. And then the Cassandra Analytics, based on some presentation that I've seen at that Cassandra Summit. And I knew it was supposed to be much faster, but not yet released. So without any additional Cassandra infrastructure, that was a big selling point. But I managed to convince the extended team and my manager that it's worth testing it in spite of. So what was required for that? Of course, first Cassandra, and at least 4.0. Fortunately, we were on 4.0. We have other projects which are running on Cassandra 3, where it would have been nice to use as well, but that's it. The Cassandra Sidecar, a Spark cluster, in our case, I used the AWS EMR. Simple network connectivity between the Spark instances and the sidecar and the jar. So first the sidecar. Then when I tried it, there wasn't. There is a very recently I tried installing and using it. Also, back then I didn't find any released RPMs or do all those things. As a side note here, I'm not a Java developer, so but that's even more. If I manage to do that, everyone should do. As mentioned before, YAML configuration file, again, it's very well documented there now, and with the comments in the YAML file. I also needed to modify go-to-back and set up the service. So the modifications that I did first, the startup script, it's auto-generated by Gradle, so I had to do some changes. The most obvious one was that the log deal is set to have home logs, and that is the installation path, and that is definitely not okay for production. And since I modified that, I also did some other changes that could have been injected from outside through the environment variable. But I think it's only these three things regarding the location of the temporary folder, since the default one is restricted and get JNA exceptions. If you put in a folder with no except security. In the YAML, again, there are lots of things there. What was important for me, of course, the port by default 9043 needs secure credentials because it needs to discover the key spaces, I think, and the GMX credentials. And very, very important, the bandwidth limitations. Return to this, and the vertex number of vertical instances. By default is 1, and now it's been a while since I've been testing this, but what I remember is that with the default, the sidecar wasn't able to fill the bandwidth allocation, but I'm not 100% sure. I guess it also depends on the kind of files that you have, the sizes, the number of files. But on the other hand, if you put more, it will affect, for sure, it will impact the security usage. The logback was fine. So there were a couple of things that were set on debug. One was SDL, and the other debug pattern. And on the first, I'm not sure if you either it was dev or production. I think it was dev. It crashed the sidecar because, as I mentioned, I was logging a different partition and then got filled. It was funny because I noticed and I managed to actually complete the test by going around to each dev instances, delete files, and restart the sidecar. And the problem was not only filling that partition, but also the CPU couldn't keep up with archiving the log files. That was the most intensive thing. So it's logging a lot. But the good thing here is that the Spark task finished, although it took much longer, and that increased confidence about how reliable this is. Moving to AWS EMR. Now, this is AWS service, just creating and setting up EC2 instances for Spark cluster. It's doing a lot of Spark things. It's not a serverless service. You do get instances. I think there is a serverless option, but I prefer to have servers where I could go in, SSH, and check the settings. By now, I could probably also try serverless. It's not really needed, since this can be very easy to raise the get some tasks to execute and then everything. It's very easy to script. It's just a lot of parameters. Unless you are very familiar with it, the easy to use the suggested points. It will create subnets or change subnets, YAMLs and so on, and then you can see what it did, copy those, modify them, Terraform. And then you have to choose some instance types for the primary, core, and task roles. And the AWS guide separates you on what kind of workload are you expecting. I think it's fairly safe to say that for Cassandra Analytics, you can expect it to be memory intensive due to all the compaction that will happen. That's in memory. It's I think it probably, if the memory is not enough, it will fall back to disk, but it's definitely better. So I use those R8G for large instances. The number of instances depends on, of course, on Cassandra's scale and bandwidth. What is nice is that this scales very, very nice. So basically, you have to see how many instances do you need. You want to have a good usage of the Spark cluster in order to properly use your money. You don't want to have too few, because you'll end up with unused sidecar bandwidth. And once you determine ratio of how many instances you need for a given number of given size of Cassandra cluster, it's very easy to use that ratio in production if you keep the same settings. And in my case, it was even nicer. It was 1/3, so very, very easy. We have the parameters there, but we can go to that. This is AWS EMR. We have the network. Well, it's simple to write. It's not that easy to do with all the AWS settings. I needed port 9043 for connections between from Spark to Cassandra Sidecar. For EMR, that's internal EMR, but I still needed to know what is happening because I actually deployed AWS EMR instances in the same subnets as Cassandra. So that I had enough room there. There was no, it was simpler for me to do that. And of course, it helps to have what to pay for. But let's start when you start the tasks. And the jar and the code. I started from the Cassandra Analytics example. I made the fork. It's new. That's I guess the core of the code is not much, which is good. As I'm not a Java programmer. What I'm doing there is I'm loading some settings from a YAML. The first step is just to export a subset of columns for all of them. I have two operations available. One is single count. That is a good it's a good test because it will go through all, it guaranteed to go through all the records and actually without producing anything compared to SQ or this. Second, we export to S3 as mentioned in the previous presentation. It's very, very easy to export various formats. The last, like before logging is the CSV options. It's also very nice is that it's possible to export directly to S3 without going through at all through the file system. I was lucky that I had people in other teams that help those S3 settings. But yeah, that's well known in the Spark environment. Just build with Gradle on that. Some issues that I had. First, when I started working, we didn't have Windows support. There was a PR I had to get to cherry pick those commits in my branch. There was also a thing that another issue that I did document. I think it was solved with a mismatch. One was expecting IP, the other was giving FTP. More serious thing that I report, some contribution, that sometimes the list of IPs from the configuration was used instead of the full Cassandra IPs, which is easy. I guess it was easy to not to see this in development or even in production if you have some sort of agent that is putting all IPs in the configuration. It's then when that was happening, the task will fail, not able to issue quorum. Even more, but even stranger, but actually helping diagnosing this was that if you put 2/3 of the IPs, the task will pass. You will get quorum, but you will get snapshots created on all those, but deleted only on those lists. So the code was mixed. Some parts was doing auto discovery of Cassandra, others just this configuration. But yeah, that's fixed now. And a minor thing with sidecar RPM. And actually, naming problem and bigger problem here was since I started very early, like it was 0.1, before 0.1, the name of the RPM package changed without the file name. That was kind of confusing. Suddenly, Now, to deploy it in production, the question of what limits do we set in order to we want to maintain the SLA. So you can have one, prevent hitting the production, because after all, the primary goal of the Cassandra cluster is to serve read writes. This export was sort of a sideshow. All impact is through sidecar, which is a very good thing. In worst case scenario, I guess it would be easy to limit the sidecar process. It was needed to have these settings, the bandwidth settings for this forward, and that will affect directly the disk I/O. CPU is CPU impact is easily controlled by the number of vertical instances. And yeah, for disk I/O, you need to know how much can you go, since it will not go through Cassandra. The question is how much disk I/O can dissipate. Specifications, and in my case, since I was using Medusa, it was very easy to use the setting that was already put in Medusa for the limits. And yeah, then it basically you have these four cases: CPU and data load usage. Data, if both are low, it's great. There's no problem. High bandwidth, you don't have a lot of data. You get straight fast to Spark. The only question here is why you scale down the cluster, but that's. The second was my case. Since I had low CPU usage, it was okay to have a high bandwidth, and it was actually needed because of the high data load. If CPU usage is high and data load is low, then you will need a lower bandwidth, but you will not need higher bandwidth anyway, since the data is low. And yeah, if both are high, probably still that would be an issue. This was what happened during execution. On the top are Cassandra metrics, Cassandra instance metrics. The first one is the network bandwidth out. You can see hitting the limit. The spike, that very threatening spike there, is actually the Medusa backup kicking at 12 o'clock. Incremental backup. It would have been a problem if I have a full backup once. That would have been a problem, but it wasn't the case. So we need to be careful about other things happening. And there were 3 tables exported there. On the right side is the CPU usage. Again, you can see the very low normal CPU. I was using, as I mentioned, I was using 2 vertical instances. And the bottom is the CPU usage on the Spark EMR cluster. It reached 89% top on the largest table, which is that's what you aim to see with Spark. That the cluster is just the proper size. A very nice thing was that before deploying in production, it was a question of how much will this take, how much will this cost. It was evaluate the execution time. This very complicated formula. Take the stage execution time and multiply it by the factor of the how large is the production table size per node compared to the stage. And since both Cassandra and Spark scale very well, this was surprisingly accurate, because it doesn't really matter how large the Cassandra cluster is. Spark will not care, since you will scale it, you will also scale it. And again, I was very surprised that the estimation was much closer than I expected. You do get, as you can see in this, you do get some leftovers. You will get Spark tasks that will take much longer than others. But that's something that, as far as I know, you cannot avoid in Spark anyway. There are specific Cassandra reasons, but that is happening anyway in Spark. One note here is that I'm using SESS. It's legacy cluster in some ways, and that also meant it had to do a lot of contractions in memory. I'm sure it has implications. Other usages, as I mentioned, after I had this tool available, it became interesting to use for other things. May or June this year, had a problem where I needed to check the executions of some queries. The Java application that was using Cassandra was using this string data Cassandra framework, which doesn't seem very active. So it allows enabling tracing per query, but it wasn't exposing the tracing ID, which means it's I was getting the logs from the application. You have this query, can you look at it? No, I cannot even do tracing because I don't have the ID. So I spin up a Spark EMR and run this in Scala console. Basically, that's the Scala syntax for select filtering the session status and system traces by hour, minute, and second. The good thing is that it was doing those things with parameter stuff to see the IP of the caller instances and link that with the report data because it was reported in the log, and then get the session. Well, the only thing here is that by default the sidecar blocks its system spaces, which makes a lot of sense, but at least another usage, I got a question how much actual data we have when we want to migrate to something else. My first idea, okay, I'll use this vector storage load the metric, which is good, but it's not that. Actually, there are a lot of issues here that it includes more than data. It's affected by compression factor. You have Thompson. So it's actually it will just give order of magnitude. The next option with metrics was to use estimated partition count and estimated partition size. That was better in some ways, but that doesn't partition count disregard tombstones and duplicates will be affected by this too. And as I mentioned, with STSS, you get duplicates, not even use case. And I got this. To count the actually get the exact count of the partitions and use that partition size. And I think the SDN will quite accurate. I don't think we have time for so. This is the creating a cluster. I am injecting some parameters, IPs. It's about 15 minutes. That's quite okay. there is time for that. Okay. Maybe I'll jump ahead to show. You get a default Spark UI in AWS EMR, so you can use that to monitor it. And yeah, it's I was including in the presentation how to use Scala console to query Cassandra, and you can do analytics queries. They will take time depending on the table size workload. It's in my case very quickly, 5 minutes and 1 hour. Yeah, that's on the table size. 1 hour was for a table that was taking on 60% data load. That's all. Any questions?
And how long does the exports take with Cassandra Analytics?
Depends. For me, it took about 3 hours, and that was for about 1 terabyte of data per node. And that will scale, as I mentioned, that will scale quite well. It was the same, and that was very close to the number I was predicting. It's probably possible to make it even faster by running the 3 export jobs in parallel in the same time, not sequentially, because you'll get a better usage of the bandwidth, but that's a very small one. And but it depends a lot on the bandwidth settings, how much bandwidth your instances will allow. Like, I can easily see that having to be reduced by half, that it will be twice as much. So.
Did you have to build the RPM because you did this before we cut a release, or is it because what we released was not working? It's pre-release.
Pre-release,
Okay.
and I was also for the sidecar. I don't remember if I have anything that I modified in the sidecar or not. But yeah, it was pre-release.
Okay.
And then I didn't even saw that there is a place with RPM harvest. I already had a build process.
I have one small comment that we talked before, and you mentioned that there was like one RPM issue that you fixed, and it was minor. But I think like even that one line change is very useful for other people that might be trying this. So I would encourage you to like keep, or anyone like to keep contributing, because like everyone benefits, and that's the kind of the spirit of the community work.
Actually, I fully agree with what was mentioned earlier, that it's much easier to contribute to this than to Cassandra.
We need to fix that.
Let's see.
Well,
Spark
earlier.
is over there and continue.
It's, I would say it's normal. Cassandra is slightly larger.
It's almost a teenager.
And all the parents with teenagers like, yeah.
Yeah.